Hello my precious friends, I really hope that you are doing great. Welcome to our today's class. It's our 10th and last lesson on the topic formula and variation. So we are looking at our example number 3, which is a past Kcse question tested in 2010, paper 2, question number 23. So it is a question worth 10 marks, and it reads that in a uniformly accelerated motion, the distance s meters traveled in a time t seconds varies partly as the time and partly as the square of the time. So we are having s, the distance s, which is which partly varies as the time. Of course, time is represented by t, and the same distance is also and partly as the square of time. So it also partly varies as the square of time. So of course this one simply means that s, so this implies that s of course will be equal to kt, of course, where k is the constant of this particular partial variation. Then of course this one simply means that the distance s is also equal to, let the other constant to be ct squared. Then because of the word partly, it simply means that we are dealing with partial variation. Therefore, we are going to separate the quantities, of course, with an addition sign. So this one simply means that s will actually be equal to kt, then of course plus ct squared. That a uniformly accelerated motion, the distance s meters traveled in a time t seconds varies partly as the time. So s varies partly as the time and partly as the square of time. So that is t squared. Then we are told that when s is equals to 2 seconds and the distance traveled is 80 meters. So I'm going to substitute these two conditions so that I can get the constants, the value of the constants c and k. So I'm told that t is 2 seconds when s, the distance, is 80 meters. So that means 80 meters, which is our s, will be equal to the constant k. Then of course the time is 2 seconds. So this will be 2, then of course plus the other constant c into 2 seconds. So this is 2, but because it is t squared, this will be 2 squared. So this simply means that 80 will be equal to 2k, then of course plus 2 squared, I'll get 4. So this will be 4c. So this will be my first equation. Then the second equation, I'll substitute the other conditions, and we are told that when the time is 3 seconds, the distance traveled is 135 meters. So I'll substitute in the same equation. So the distance is 135 meters, so I'll have 135 meters being equal to k. So this is k, then into the time is actually 3 seconds. So this will be k into 3, then of course plus the constant c, then of course into the constant into the time is still 3 seconds, but because it is t squared, I'll get 3 squared. So this will be 135 being equal to k multiplied by 3, I'll simply get 3k, then of course plus 3 squared, I'll get 9. So this will be 9c. So this will be my second equation. Therefore, I'm going to use elimination method to find the value of the constants c and k, so that I can express the equation in terms of s and t. So remember, here we are answering part A of the question. So I'm using elimination method. Therefore, I'll write 135 being equal to 3k, then of course plus 9c, which is my equation Roman 2. Then I'll also write with the equation Roman 1, which is 80 is equals to 2k. So this is 2k, then of course plus 4c. So I want to use elimination method. So that simply means that one term has to be constant, so that when you subtract you get 0. So to achieve that, I'm going to eliminate k. Therefore, I'll multiply the first equation with the coefficient of k for equation 2, which is 2. Then I'll also multiply the second equation with the coefficient of k for the first equation, which is actually 3, so that I can balance the values of k. So this is going to give me the following. So I'm going to get the following. So of course I'll get 135 multiplied by 2. I'm going to get 270. So I have 270 being equal to, so I'm having 2 multiplied by 3k. I'll simply get positive 6k. Then of course plus 9c times 2, I'll get positive 18c. Then of course 80 multiplied by 3, so 80 by 3, I'm going to get 240. So 240 being equal to, of course 3 multiplied by 2k, I'm going to get 6k. Then of course 4c multiplied by 3, I'm going to get positive 12c. So plus 12c. Then I'm going to subtract the two equations so that I can eliminate k. So 270, of course, minus 240, I'm going to get positive 30 being equal to, this one will give you 0. Then of course plus 18 minus 12, I'm going to get a positive 6. So this will be 6c. So that means 30 is equal to 6c divided by 6 divided by 6. The value of c will actually be given by 30 divided by 6, which is going to give me a positive 5. Then I'll substitute in my first equation to get the value of the other constant k. So I'll say substituting. So I'll have substituting c is equals to 5 in, I'll substitute in my first equation, in equation Roman 1, I'm going to get the following. So if I substitute where I have c, I'm simply going to substitute with positive 5 that I've gotten. I'm going to have the following. So remember my equation Roman 1 was this equation here. It was 80 is equals to 2k, then of course plus 4c. So if I substitute c being equal to 5, I'm going to get 80 being equal to 2k. So this will be 2k, then of course plus 4 into the value of c, which I've gotten to be 5. So that means 80 will be equal to 2k, then of course plus 4 by 5, I'm going to get positive 20. So that means 2k is equals to, if you take 80 minus 20, you're going to get positive 60. So divided by 2 divided by 2, it means that the value of k will be equal to 30. So k will be equal to 30. So it means that the equation connecting these two variables, that is t and t squared, that is t and k, will be given by the following. So the original equation was s is equals to kt. So this was kt, then of course plus ct squared. So if I substitute, it means the equation connecting s and t will be s is equals to, the value of k, I've gotten it as 30. So this will be 30t, then of course plus the value of c, I had gotten it as positive 5. So this is 5, then of course t squared, 5t squared. So we have expressed s in terms of t. So the other way they can ask it, this question is that that is, you can either be told to express s in terms of t, or you simply find the equation connecting s and t. So this is the equation connecting those two. Then we are going to move to part B Roman 1 of the question. So this is part B Roman 1. So in B Roman 1, they want us to make find Roman 1, that is the distance traveled in 5 seconds. So I'm simply going to substitute in the equation. So I'm going to have s being equal to 30. So we are told that in 5 seconds, that means t is actually 5. So this will be 30 into 5, then of course plus 5 into t squared, of course t is 5. So this will simply be 5 squared. Now if I substitute in the equation, this is what I'm going to get. Let me rub this side so that I can create some working space. So this will be given by, so this is s is equals to 30 multiplied by 5. I'm going to get 150. So this is 150. Then of course plus 5 multiplied by 5 squared, so I'm going to get 125. So I'm going to add 125. So if I add these two, 125 plus 150, I'm going to get 275. So 275. So the distance, remember the distance was in what units? Meters. So it means this is for B Roman 1, the distance traveled in 5 seconds will actually be 275 meters. 275 meters. Then we are going to move to part B of the question, whereby that is B Roman 2, whereby we are asked to find, so this is B Roman 2, we are asked to find the time taken to travel a distance of 560 meters. So again, we have the formula for distance. So distance was S is equals to 30t, then of course plus 5t squared, plus 5t squared. So we are told the distance is 560. So that means 560 will be equal to 30t, then of course plus 5t squared. Now remember, this will give us a quadratic. So I'll take this one to the left so that my quadratic will be 5t squared, then of course plus 30t. If it crosses equal sign, it will become a minus 560, then of course is equals to 0 on the other side. So to solve this, I'm going to use the quadratic formula, which simply requires that t will be equal to negative b plus or minus the square root of b squared, then of course minus 4ac, then of course the whole thing divided by 2a. So if I may write the quadratic equation here, which is usually ax squared plus bx, then of course plus c is equals to 0. It simply implies that the value of c will be negative 560, then the value of b will be positive 30, then of course the value of a will be positive 5. Again, let me clean this area so that I can use it for to perform my working. So I'm going to get the following. So I want to substitute the values in the quadratic equation. So I'm going to get the following, t being equal to the following. So negative b will be actually negative 30, because the value of b is 30 clearly. Then of course plus or minus the square root of b squared. So my value of b is 30, so this will be 30 squared, then minus 4 multiplied by a, the value of a is 5, then of course multiplied by the value of c, which is negative 560, then I close the bracket, then the whole thing divided by 2 multiplied by a, which is 5. So this will be negative 30 plus or minus, let me feed this on my calculator, 30 squared, then of course minus 4 times 5, then times that is 30 squared minus 4 multiplied by 5 multiplied by negative 560. I'm going to get the root of, so this will give me the root of 12, so this is 12,100, then divided by 10. So this will be equal to negative 30 plus or minus, so the square root of that, I'll get 110. So that is the square root of 12,100. The square root is 110, then of course divided by 10. So this one means either the value of t is equals to negative 30, then of course plus 110, then divided by 10, which is going to give me, so negative 30 plus 110, then close bracket, divided by 10, I'm going to get 8. So the first value of t is 8. But what was t representing? T is representing time in seconds. So this is 8 seconds. Or the other possible solution is the other value of t will be given by, so we'll say or the other value of t will be negative 30. We pick this one being a negative. So remember, this should be plus or minus. It is plus or minus. So I'll pick the negative. So minus 110, then the whole thing divided by 10. I'm going to get the following, negative 30, then minus 110, close bracket, divided by 10. so I'm going to get negative 14. So the other possible value of t is negative 14 seconds. But we know that time is actually a scalar quantity, therefore it cannot be negative. Therefore we'll conclude and say that the time taken to travel for 560 meters t will actually be given by 8 seconds. It will be 8 seconds. Then we look at our fourth example, which is our last example, which reads that quantity. Remember, this is also a past Kcse question tested in 2015, paper 2, question number 21. It is that a quantity P varies partly. So P is varies partly as the square of M and partly as N. So this one simply means that P will actually be given by, it partly varies as the square of M. So this is M squared, which will simply imply that P is equals to the constant K M squared. Partly varies as the square of M and partly as N. So the same P is also varying partly as another quantity N. So this one implies that P will be equal to another constant C then multiplied by N. So because of the word partly, it simply means that you are dealing with partial variation, therefore we need to add the terms. So that means P will be given by Km squared, then of course plus Cn, where K and C are constants of the proportionality. So we are given conditions that P is 3.8 when M is 2. Therefore I'll substitute P is 3.8, so this is 3.8 is equal to, so remember we are answering part A of the question, whereby we are told to find the equation that connects P, M and N. So we are answering part A. So I'm told that P is 3.8 when M is 2. So this will be K into my M is 2. So this will be 2 squared plus C into the N is negative 3. So into negative 3. So this will be 3.8 being equal to 2 squared, I'll get 4K. Then of course negative 3 times C, I'll get negative 3C. Therefore this is my first equation. Then I'm also told that P is negative 0.2 when M is 3 and N is positive 2. Therefore, if I substitute in this same equation, I'll get the following. So P is negative 0.2, which is equal to is equals to K into M. My value of M is actually 3. So this will be 3, but because it is M squared, this will be 3 squared. Then of course plus C into N. The value of N is positive 2. So this is negative 0.2 being equal to 3 squared, I'll get 9. So this will be 9K. Then of course plus 2C. So this will be my second equation. Then I'm going to use elimination method to find the values of K and C. So to achieve that, I'm going to arrange the two equations. So the second equation was negative 0.2 is equals to 9K, then of course plus 2C. The first equation is this one here, which is positive 3.8 is equals to, I am having 4K, so this is 4K, then of course minus 3C. So this was my first equation. The second equation is 3.8 is equals to 4K minus 3C. The first equation was negative 0. So the second equation was negative 0.2 is equals to 9K plus 2C. Then the other one is 3.8 is equals to 4K minus 3C. So I want to eliminate one of the variables. So I want to eliminate, let me eliminate C. So I'll multiply this equation with the coefficient of this, which is negative multiplied by negative 3. Then this one I multiply with the coefficient of C on the upper side, which is positive 2. So if I do that, I'm going to get the following. Let me separate my working here. So if I multiply, I'm going to get the following. So I'm having negative 3 multiplying with negative 0.2, which is going to give me positive 0.6. So 0.6 being equal to, so 9K multiplied by negative 3, I'll get negative 27. So minus 27K. Then of course I'm going to add so plus 2 times negative 3, I'll get negative 6c. So this will give me negative 6c. So I'll get negative 6c, which simply implies that I'm having 0.6 being equal to negative 27 k, then of course minus 6c. Then if I multiply the second equation, I'm having 3.8 multiplied by 2, I'm going to get 7.6. So I'm having 7.6 being equal to 4k multiplied by 2, I'm going to get positive 8k. So 8k, then of course 2 times negative 3c, I'll get negative 6c. Then if I subtract the two equations, I'm going to get the following. So I have 0.6 minus 7.6. 0.6 minus 7.6, I'll get negative 7. So negative 7 is equals to, I'm having negative 27, then of course minus 8, which is going to give me negative 35. So negative 35 k, then of course negative 6c minus 6c, I'm going to get a 0. So this will be 0. So I'll divide through by negative 35. I also divide through by negative 35. So that means the value of k will be equal to negative 7 divided by negative 35, which is going to give me 0.2. So this is 0.2. Then I also substitute in my first equation to get the other value of c. So k is 0.2. So let me substitute. Let me rewrite it. So substituting k is equals to 0.2 in let me substitute in the second equation because I can see it is easier to work with it. Substituting in the second equation. So remember my second equation was this one here, which is negative 0.2 is equals to 9k, then of course plus 2c. So I'm going to substitute in that equation. So if I substitute, I'm going to get the following. So this is what I'll get if I substitute. So I'm going to have the following. So I'll have negative 0.2 being equal to 9k, then of course I have the value, I already have the value of k, therefore I'll just substitute it. So where I have k, I'll substitute with 0.2, then of course plus 2c. So plus 2c. So this will be equal to negative 0.2 being equal to 9 multiplied by 0.2. I'm going to get 1.8. So this is 1.8, then of course plus 2c. So negative 0.2 minus 1.8, I'm going to get negative 2. So that means negative 2 is equals to 2c. So I divide through by 2, also divide through by 2. So that means the value of c will actually be equal to negative 1. Therefore, I was asked to find the equation connecting p, m, and n. So remember the equation was this equation here, which was p is equals to km squared, then of course plus cn. So if I substitute, the equation will be p is equals to k. So my value of k was 0.2. So this is 0.2 m squared, then of course plus the value of c is negative 1. So this will be minus 1 multiplied by n, which can also be written as p is equal to 0.2 m squared, then of course minus n. So we have answered part A of the question. So that is the question connecting p, m, and of course n. Then we are going to look at part B of the question. So in that was part A Roman 1. So in part A Roman 2, we were asked to make find the value of that is in Roman 2, find the value of p when m is 10 and n is 4. So I'll simply substitute p is equals to 0.2 m squared, then minus n. So this will be equal to 0.2 into m. So I'm told to find p when m is 10. So this will be 10 squared, then of course minus n. My n is actually 4. So this will be given by 0.2 multiplied by 10 squared. I'm going to get positive 20. So this is 20, then of course minus 4, which is going to give me a positive 16. So positive 16. So that is the value of p when m is 10 and n is 4. Then we look at part B of the question. So in part B, we are told to express m in terms of p and n. Express m. So we just need to make m subject of the formula. So remember the equation connecting the 2 is p is equals to 0.2 m squared then minus n. So we want to make that is express m in terms of p and n. So we simply need to make m subject of the formula. So I'll have 0.2 m squared being equal to, I'll take n to the other side, so this will be p plus n. Then I'll divide through by 0.2. I also divide through by 0.2 so that these ones will cancel out. So that means that m squared will be equal to p plus n, then of course divided by 0.2. So we need to make m subject of the formula. So the only way we can achieve that, of course, is if we square root both sides of our equation. So if I square root both sides, I'm going to take a square root on this side and also square root on the other side. The square root is plus or minus. So that simply means that m will actually be equal to plus or minus the root of p plus n, then the whole thing divided by 0.2. So we have answered part B. Then we move to part C. If p and n are increased by 10, find the percentage increase in m correct to 2 decimal places. So we'll find the new value of p. So we'll have p, the new value of p. It has increased by 10%. So this will be 10 plus 100, which will give you 110 over 100 multiplied by the original p, which is going to give you 110 divided by 100. You're going to get 1.1. So this is 1.1 p. Similarly, we also have a new value of n. N has also increased by 10. If p and n are each increased by 10, so the new value of n will also be 110 over 100n, which will be equal to 1.1n. So we are told to find the percentage increase in m. The percentage increase in m. So we need the new value of m. So m new, the new value of m will be given by plus or minus the root of. I'm going to substitute the new values of p and n. So p is 1.1. So I'm having 1.1 p, then plus the new value of n is 1.1 n. Then of course the whole thing was divided by 0.2. So we need to find the percentage. Percentage increase. So to get the percentage increase, we just need to get the increase first, then of course minus the original value, then multiplied by 100%. So percentage increase will be given by the following. So this will be percentage increase or the change percentage increase will be given by, we'll take the increase divided by original value, then we multiply it by 100%. So this will be given by, so percentage increase will be given by the following. So the increase will just be the difference between this value and the original value. Remember, this is our original value of m. So I'm going to take plus or minus the root of the second value, which is 1.1p, then of course plus 1.1n, then the whole of it is divided by 0.2, then minus, so this is the increase, plus or minus the original was the root of p, then of course plus n, then divided by 0.2. Then I'm going to divide with the original value, which is again plus or minus the root of p plus n, then divided by 0.2. Then if I want to get it as a percentage, I'll multiply with 100%. So I'm going to multiply this equation by 100%. So this one, let me remove this. So I'm going to multiply this equation by 100%. So this will give us the following. So I can separate some variables from this particular equation. Remember, 1.1 is constant. So I can write it as plus or minus. So remember, plus or minus will just cancel out from both sides of the equation. So I can write this one as the root of, I'll have the root of, so I'll factor out 1.1 over 0.2. Then we have p plus n. So p plus n. So I've just factored out the common factors. Then minus, plus or minus will just cancel out with the one on the denominator. So I'm also going to separate. This one is the same as saying, remember the coefficient of p and n is 1. So this is 1 over 0.2. Then of course into p plus n under the root. Then the whole thing divided by 1 is the coefficient of p and n. So I'll factor it out. So divided by the root of 1. Then on the denominator we have 0.2. Then into p plus n. Then the whole thing multiplied by 100%. So I'm simply factoring out the coefficient so that I can make my work easier. So this is going to give us the following. So remember that p plus n is constant. So I want to separate these. So if I separate the variables alone, I'm going to remain with the root of. So this will be the root of. So I'm going to have the root of 1.1 then over 0.2. Then remember 1.1 over 0.2. Then I'm going to multiply with multiplied with the root of p plus n. P plus n, that is under the root. I'm separating the coefficients with p and n. So this is the same as saying the root of 1.1 over 0.2 divided by the root, multiplied by the root of p plus n. Then minus, this one is also the same as saying the root of 1 over 0.2 multiplied with the root of p plus n. Then the whole thing divided by, I'll also separate these, the root of 1 over 0.2 multiplied by the root of p plus n, of course under the bracket, so that the square root will affect everything. Then of course I'm going to multiply with 100%. Now you can see that the root of p plus n is constant, so I can take it out. So this is the same as saying the root of p plus n, because it is common on the numerator. So into the root of 1.1 over 0.2 minus the root of 1 over 0.2 that way. Then divided by, I'm also having the root of 1 over 0.2, then multiplied by the root of p plus n, that is under the root, then times 100%. So clearly you can see we have something which is common, that is the root of p plus n is going to cancel out. So I'm going to remain with the following. This is what I'm going to remain with. So we are remaining with the root of. So we are having the root of, that is the root of 1.1 over 0.2 minus the root of 1 over 0.2, then the whole thing divided by the root of 1 over 0.2, then multiplied by 100%. So if I take the root of, so I can feed this on the calculator directly. This is how you are going to press on the calculator. You press opening bracket. So let me work out the numerator. So the root of open bracket 1.1, then divided by 0.2, that is under the root, then minus minus the square root of open bracket 1 divided by 0.2 close the bracket. So let me see, 1.1 divided by 0.2, I'm going to get 5.5. So 1.1 divided by 0.2, I'll get 5.5. So this is the same as saying the root of 5.5. Then of course minus 1 divided by 0.2, I'll get 5. Minus the root of 5 minus the root 5 divided by 1 divided by 0.2 will still give you 5. So divided by root 5, then multiplied by 100%. So this is going to give us the following: open brackets, the root of 5.5 minus root 5, close the bracket, then divided by the root of 5. So then of course times 100%. I'm going to get, I'm told to give the answer to 2 decimal places. So I'm getting 4.80885. So to correct to 2 decimal places, my answer will be 4 point 2 decimal places, 4.88%. So thank you very much for accompanying me until the end of this particular